Hello and welcome back. In the previous video, we introduced the subject of Chapter 15, which is the study of thermodynamics. This field studies processes by which energy is transferred via work and heat. The first law of thermodynamics is that the change in internal energy is equal to heat added to the system minus work done by the system. So this is where we're focusing in for this video, is on the first law of thermodynamics. Recall our definition of work from back in chapter 6, 7-ish. Work is equal to the integral, this is just the area under the curve, on the force times the cosine of theta versus displacement graph. So for our purposes in chapter 15, theta is either going to take on a value of 0 or 180 degrees. The cosine of 0 degrees is 1. The cosine of 180 degrees is -1. So in other words, I can replace cosine theta by either 1 or -1. So work can be written then as just the integral of f dx. Notice I've let cosine theta be 1. And work is greater than 0 if the displacement is greater than 0. And work is less than 0 if the displacement is less than 0. So if the system is expanding, dx is going to be positive, work is positive, work done by the system is positive. If instead dx is negative, then the system is collapsing and work would be less than 0. Writing force as pressure times area, I can re-express then work as the integral of pressure times area times the infinitesimal displacement. And then gathering up the area and then infinitesimal displacement as the change in the volume, or the infinitesimal change in volume. So I can write then work as the integral of pressure times the differential change in the volume. So the integral of p dv. Again, notice work is greater than 0 if dv is greater than 0. So if the system is expanding, then the work done by the system is positive. The force it's exerting and the displacement is in the same direction, so the work is positive. If instead the system is collapsing, the system is still pushing outward on the boundaries, but if the system's collapsing, then the force being exerted by the system and the displacement are 180 degrees different, and work is negative. So if the volume is changing to become more negative, then work is negative. If the volume is changing to become greater, then the work is positive. So another way I can write this is, or if delta V is greater than 0, or if delta V is less than 0. It's just the change in the volume, not the volume itself. All right, so there are several different systems that we want to look at with the first law. Now notice that I can rewrite the first law with our definition for work then inserted. So the change in internal energy is equal to the heat added minus the integral of p dv. So there is the first law. Here is the first law. This is how we want to use the first law. So remember that this is just the area under the pressure versus volume graph. Pressure, I've misspelled pressure, excuse me here. Pressure versus volume graph. This is called a PV diagram as well, these pressure versus volume graphs. And they are very, very important if you ever want to take the MCAT or any kind of medical examination that tests you on physics. PV diagrams, P standing for pressure, V standing for volume, diagram being the same as a graph, PV diagrams are very, very important at understanding them. So you can find the work done as just the area under the curve on the pressure versus volume graph. So we'll be looking a lot at those as we consider problems moving on. So let's talk about some different processes though, just to get an overview before we start delving in and solving problems. So it says the change in internal energy is equal to the heat added to the system minus the work done. The work done by the system can be found as the area under the pressure versus volume graph. All right. So several different types of processes that we want to consider. One is called isochoric. And isochoric is the same as, also known as, isovolumetric. Isovolumetric is much more lending itself to telling you what it is. This means stay at the same volume. So this is constant volume. So this is a process in which volume remains constant. So if the volume remains constant, then delta V, or dV, is equal to 0. And so if dV is equal to 0, 0 times anything is 0, therefore work is 0. And any change in internal energy is just going to be equal to heat added. Okay, so the first law then just becomes delta U is equal to Q, because W is 0. That's for an isochoric or isovolumetric process. All right, another type of process is called isothermal. And an isothermal process, as the name implies, is a process in which temperature remains constant. Now recall from chapter 13 that the internal energy scales as temperature. So the temperature that you read on your thermometer is a measure of the internal energy of the system that the thermometer is in contact with. So if the temperature isn't changing, then the internal energy is not changing either. So delta U is 0. So what do we get from the first law? We get that Q is equal to the integral of P dV. So any heat added to the system has to be offset by work being done by the system. That's what the first law is telling us when we have an isothermal process. Okay, another type of process is called adiabatic. And an adiabatic process is a process that is done very quickly or in a highly insulated environment. So process done very quickly or completely isolated such that no heat is allowed to flow at all. So no heat can flow out of the system and no heat can flow into the system. So Q is equal to 0 for an adiabatic process. So what do we get from the first law in an adiabatic process? We get any change in the internal energy is going to be due to minus the work done by the system. So this is our first law for an adiabatic process. The last process we're going to consider is called isobaric. And an isobaric process is a process by which pressure remains constant. Okay, and if the pressure is constant, looking at our definition for work, if pressure is constant, it can come out from underneath the integral. And so when that happens, then I just have the integral of dV, which is just the change in the volume. So now I can write work as that pressure times the change in volume. So the first law for an isobaric process is that the change in internal energy is going to be equal to the heat added minus P delta V. Notice I can only write it as P delta V for an isobaric process, not for any other process. So these are the 4 processes that we're going to be looking at, and you can see the consequences to the first law as the boxed in values for each one of the processes. So let's pick up here next time and work a problem applying the first law to a system from one of the problems in your textbook. So we'll see you next time.